Okay, good morning, everyone. I'm maybe a couple of minutes too early, so I'm just going to wait a few minutes just in case some people join us a little late. So just bear with me for a while. All right, so I may as well get started. My name is Dermot O'Connor, and I will be presenting this module to you. Can I just maybe confirm from somebody that you can hear me and you can see my screen okay? Can I just check again? People can see my screen and hear me. Okay, I think so. Yeah. All right. The other thing is, uh, I'd actually prefer people just speak out if they want to ask questions or make comments or whether rather than typing them into the message system within Zoom because I don't tend to keep an eye on that. So feel free to, and don't be shy to just start speaking whenever you need to. Right, so I may as well get started. And I'm going to turn off my camera. So given that everybody has found the Zoom link, I take it that you've received my two emails. And uh, in in the first email, I gave you a couple of links. One is to the website that you're looking at on my screen now. This is where I will be publishing all of the material for this module rather than putting it on Moodle. I'm going to use this website instead. And I think if you've had a lecture with Roseanne and Frank in the Web App Dev 2, they use the same approach as myself. So did somebody want to ask me a question? No. Okay. False alarm. That's all right. And as I also mentioned in the email, in fact, you know what I'll do? I'll just go straight into these slides because I pretty much cover everything that I want to say to you at startup in that anyway. So these cards are where these cards kind of cover topic by topic. I want to look behind this card first. In this card here behind it is where I will publish the recordings of my lectures. Now, if we go in there and if we click here, I've just put in a dummy link there for the moment, but from here on in, they will actually lead you to the recordings of my lectures. Okay, so if I go back to my homepage and I want to look behind this card first. Now, I'm not sure about your side. If anybody is actually currently logged into this website on your computer, I'm having a problem on my side, and I'm just wondering whether it's only on my side. When I click on this card, or when one clicks on this card, what should pop up is a PDF of, in this case, a set of PowerPoint slides. But when I click on it, which I'll do right now, it seems to just go into a loading spinner and it doesn't move out from there. Can anybody actually access the PDF that should appear here on their computer? Can anybody confirm to me that yes, they can actually access it? And just speak out an answer rather than typing into the messaging system, if you wouldn't mind. Or is everybody Nobody is speaking, so I'm assuming everybody is getting the same issue as me. I'll just wait in case somebody can confirm that no, they actually can access the PDF. No. Okay, I'm going to take that to mean that this part isn't working for you. Not sure why that's the case, though. It's not working for me either. But what I will do as a short-term solution is I will publish the slides in PDF form onto the Slack channel, and you can access them from there. But we need to resolve this problem, obviously, because I don't want to keep uploading the slides to Slack. Right. Anyway, if we were able to access those slides, this is what we would get. So you can just follow me really on the screen. So really all I want to do through this set of slides is just give an overview, quick overview of the module, and then we'll start into the first main topic. So as you know, there are two groups taking this module, software systems development and software systems practice. And of course, by the way, welcome to all the Nanjing students who are with us here for this academic year. I hope you've settled in okay. A lot of the stuff on this slide now, I have provided information to you via the email there last week, but so just very quickly, we do use Moodle, or I do use Moodle, but only for submitting assignments from your part. If anybody has been unable to register on Moodle, you can self-register or self-enroll, as Moodle calls it. Sorry, just 1 second now. And the way you self-enroll is by actually just entering this URL in a browser tab and use this self-enrollment key, and that should let you in. Number two, as I've just said, all of the material though for this module is published on a website which I've just shown you. Number three, I communicate with ye and ye can communicate with me via the Slack channel. Everybody should have received an email inviting them to join this Slack channel, and you should join it straight away because that's what I will really use in the main for communicating with you. I may use email every now and again, but less frequently certainly than Slack. And really the only time I use email is if I want to notify the entire class of some event or whatever. And so all of those messages will go to either which email account. As you know, there is 1 lecture per week on this module, which will be online, and 3 practicals per week. And the 3 practicals are a reflection of the fact that this module has a very strong practical emphasis to it. And that's also reflected, excuse me, in the module's name, Agile Software Practice. Well, initially, we will try and maybe run the practicals remotely. As I think I might have mentioned in the email, we'll work over the Slack channel, but I can certainly turn up. I know there is a lab room allocated for the 3 practicals. In fact, it's tomorrow morning. It's a 3-hour slot in one of the labs, and I can certainly turn up in that lab room to meet people every now and again if they want to, if they would prefer to talk to me face to face about a particular problem they're having in a lab or more generally in the module. So we'll sort of play around with that as we work through the semester. But certainly for this week and next week, let's run it remotely, so to speak. Okay, there isn't an awful lot new on this slide, but I'm just going to pause for a second anyway, in case there are any questions that anybody has for me. No, you're all very silent. Okay, that can be good and bad, but hopefully you become a little bit more communicative as we work our way through this. That's okay for now, though. So this is really what I want to quickly run through this set of slides. Just quickly talk about what software requirements are associated with the module, and there are a number. Then I'm going to talk about the software development lifecycle, because that's really the context for everything that we do in this module. Not so much the lifecycle itself, but the tools and frameworks that support the software development lifecycle. Then we'll talk about specifically what this module's focus is, which really is, as I said, it's all about the tooling associated with aiding and automating many of the tasks associated with software development, some of which you've come across already, but I'll introduce you to some new ones. And the last item is probably the one that most people are interested in initially anyway. How is this going to be assessed? So in terms of what software you need to have installed and or what cloud services you need to register for, there are quite a few, but in fact, many of them I think you already have. And they're also required for the web app dev module. So the first thing is Node.js. You need to have that installed on your local machine, which you will be using extensively in the web app dev. I'm certainly not too concerned about the exact version that you will have. So anything around version 20.x. I think I probably have an older version on my machine, and that's fine for this module. I'm pretty sure it would be okay. An older version would be suitable for the web app dev as well. But I'll let Roseanne fill you on that. The second item on the list, Docker Desktop, that is unique to this module or specific to this module. And I'm giving you a URL there that you can click on to download this Docker Desktop application. So you need to install that locally. Now, it can be slightly problematic installing Docker Desktop in that if your operating system is, let's say, 4 or more years older, then it may complain by saying we don't support older versions of whatever operating system you're using, whether that be Windows or Mac or Linux. So some of you may encounter that problem. We'll have to see if we can come up with a workaround. You can get older versions of Docker Desktop, and it becomes an issue of trying to find an older version that works on your machine. Really, we don't need to have the newest version of Docker Desktop at all. On my computer, I have a version that's probably about 5 years, 6 years old, and it's perfect for this module. That's because the version of the operating system that I have on my Mac is about 5 or 6 years old. But see how you get on, and I do require you to install Docker Desktop straight away, because you will actually be using it hopefully in tomorrow's lab. But do get back to me if you're having any issues installed. Right, so apologies for the hiccup yesterday. Not my fault for once, but there you go. So I want to work our way through these slides and also hopefully get you started on one of the labs. So where I left off yesterday in terms of the overview, was talking about the software that you need to have installed. Hopefully, since yesterday, people had a chance maybe to install the Docker desktop, which is where I left off, because we'll try and use Docker desktop today, if possible. Get started on it anyway. Moving on from that list, everybody needs to have the Git tool installed locally. I reckon that is probably already installed on your computer, whether you've used it up to now or not. The way you check whether it's installed or not is just to, so now just give me 1 second. You probably know this already, but if you just type this command from the command line, then if it works, then it's installed. If not, if you need to go and install it, then I'm giving you a URL there just above it to achieve that. I don't really care what version of Git you have installed. It's not that critical in terms of the version, but we do use Git a lot throughout this module. VS Code is the editor that I use. You don't have to use it, but in my classes and in my labs, I use it for demonstration purposes. I think it's a good uh, editor to be aware of anyway. And I know in the web app dev too, they use it throughout that module. So there's a double benefit to familiarizing yourself with it if you're not already so. Sorry, now just give me another minute. There are a number of online accounts that you need to create for yourselves. The first one, GitHub. I hope everybody has a GitHub account at this stage. GitLab is another service that we will use about halfway through the module, I think, from there on in. GitLab has a lot of what GitHub has, but it has much more as well. So I'm giving you a URL there to create your account on GitLab. You will need to provide, unfortunately, a credit card. It requires you to register a credit card against your account. I don't see us incurring any or very minimal cost using GitLab, but as part of the registration, it requires it. Next is the AWS Amazon Web Services. You will need to create an account on that platform. Again, many of you may have already an account on it. I know for the Irish students, you would have used the AWS service in third year. So you may have an account from then. For the Nang students, you may or may not have used the service, but you will need to create an account on it. And similar to GitLab, you do need to provide a credit card as part of the registration process. And equally, I would hope that the costs you will incur will be minimal. I will certainly be reminding you what to do in order to minimize the cost. I don't see us incurring anything more than maybe $20 in the entire semester if you follow the practices I tell you to. We won't be using AWS again until about halfway through the module, but you may as well go away and create all of these. I would suggest straight away just to get them out of the way. I'll pause for a second just in case there are any questions on that list. No. So just back to my agenda. Back to my agenda. Right now. Okay. Is that letting me go back to my agenda? The gremlins at me again. Why doesn't it want me to? I'm going to stop sharing for 1 second. Okay. The next thing I just want to briefly talk about is the software development lifecycle. It's not so much that we're going to be talking about life cycles and processes extensively throughout this module, but the software development lifecycle was really the kind of inspiration for this module, and it also provides a kind of a framework for what we want to do. So in very, very general terms, there are two contrasting software development life cycles. That's how I'm framing it anyway. There's the waterfall model and the agile model. Now, I've put a strike through the waterfall model because really that's legacy at this stage. Any software team that is following that model are very much out of date, I would argue. There may be some organizations that still use it, but they're certainly in the minority. The other model I'm just broadly referring to is the agile model. Now that's kind of an umbrella name there. I'm saying there are a number of variations on the agile model. They all have a lot in common, and it's the commonality is really all we're interested in. You may have heard of Scrum, for example, which is very popular form of the agile model, Kanban, and there's lots of others. Agile as a term was very popular maybe a decade ago. Today, when we talk about the agile model, the term or the label that's used more now is the DevOps model. And you will see job advertisements in the and wherever you see your job advertisements, you don't get them in the paper anymore, but online. You'll even hear on radio and TV adverts that mention related to software development that mention DevOps. So it's very much a term that we use today. And this DevOps model, it really is an evolution of the Agile model in today's terms. And I would say that DevOps, like when we created this module, I'm talking about maybe more than 5 years ago, Agile was still the kind of label that was used then. But if we were designing this module today, then we would probably definitely use DevOps as a title for the module. That's just by the way. So I'm sure you've covered the Agile software development lifecycle somewhere in your studies in previous years, but I'm just going to quickly refresh your memory on that because, as I said, it does kind of provide a framework for some of the stuff, for all of the stuff that I will do with you. And you'll see what I mean by that when I say it provides a framework for it. So on this slide, I'm describing the Agile software development lifecycle in kind of at a high level, but it's still true to what Agile is all about. So if we start on the extreme left, let's supposing a software team is about to embark on developing an application and they've done their initial kind of user requirements analysis. So they have their user requirements for this application. And the first thing we do in the Agile approach is we prioritize those user requirements, and I'm representing my prioritized list here. And then we take an iterative approach towards implementing this prioritized list of requirements. So by that, I mean, you take the top priority user requirement or requirements, a subset of them, and you move on over here. So we've taken a small subset, the most important at the current point in time anyway, the most important aspects of the overall application's objectives. And we are going to develop those, okay? So here we are representing our most important or our top priority user requirement or subset of user requirements to date that we have to develop. And we go through kind of an iterative process in developing those. And by that, I mean, you plan out who's going to do what. You do some design, some implementation, some testing. Now, the kind of time span we're talking about here now might be, I don't know, maybe a month, maybe slightly less than that. Depends on how the nature of the application. So you're spending a short period of time developing, implementing, testing a small subset of the overall application's requirements. Okay. And I'm talking about, you're having kind of daily meetings discussing how are we getting on with the current tasks that we need to work on. Eventually, we have a working form or working version of our application or our system, albeit it only has a subset of the overall user requirements. And we subject that working version of this application or our system to a review by let's say, the team manager. We can demonstrate it potentially to the customer if it's in a form that can be demonstrated to the customer. We learn from the customer's comments on it. So we take that as feedback, and that feedback will inform the next iteration of this overall process. So the feedback might indicate that we should reorganize the remaining user requirements, or maybe add in some more user requirements based on the feedback. If the application at this stage is in a form that we can actually provide access to our end users, then we do that. So we deploy it, presumably, deploy it onto some sort of cloud platform, and we monitor the operation of that application by our user base. And we provide that monitoring of the operational side of it is also feedback to the next iteration of this overall process. I guess really this arrow here should probably be ending up kind of here, really. And we start planning the next iteration of this this approach. Yeah. So until eventually, we get through all of the user requirements. And as I said, each feedback loop may provide further user requirements or may require us to reorganize our prioritized list. So that's kind of the Agile approach. And it's a very dynamic approach. Yeah. And it's iterative and it's incremental and all of those kind of attributes. Now, this slide is telling us the exact same story, except on this slide, this may be a logo that you may have come across on the web. This is the logo for the DevOps approach towards software development. And as I've already told you, DevOps is really Agile, a modern version of the Agile approach. And it's really telling us the exact same story as the previous slide in terms of how we go about developing an application. Our starting point is always, we're planning. My mouse gone. So again, the assumption is we have our list of prioritized user requirements and we plan where will we start off. And we know from the previous slide, we take the highest priority user requirement or subset of user requirements, and we essentially implement those, do some testing, automated testing, or even manual testing. We build our application. Okay, that's not a term I used on the previous slide, but building really means kind of packaging your application. It could mean no more than just compiling all of your code into your overall application. There may be more to it though. We do some formal automated testing. We release the application to our customer base, stroke user base. We deploy it well, maybe release and deploy are kind of all the one thing, really. Okay, there may be slight differences between them. We deploy our application to a cloud service so it's accessible by our user base, and then we operate it and monitor it, operate and monitor, and we're back to here again to the planning stage where we now are planning the next iteration of this process. And on the outline of this slide, there are some of the tools and frameworks and services that software houses, software organizations use today to support this overall process. Clearly, it's not a completely manual process. It's highly automated. And it's that automation that's really what we're interested in this module. We're not so much interested in the theory of the Agile approach or the theory side of the DevOps approach. It's easy enough to understand at a fairly high level. It's not necessarily straightforward to implement it in a software team. It requires management, etc. I'm not getting into that side of it, though. It's more the tools for the automation support behind this process is what I'm interested in this module. And there are many other tools that aren't on this slide at all. I didn't create this slide. I literally did a Google search, came across it, and I quite liked it, actually. If you do Google search on DevOps image, then what you tend to get is just this part here. Yeah, you don't get the extra stuff that I found on this image. Specifically, what we will be using, well, sorry, if I just erase that stuff. The parts of this process that we are interested in this module is the build side, the automated testing side, and the deploy side. Okay. That's as much as we'll be able to achieve in our 11 weeks. Yeah. You've obviously done a lot on the coding side already. You may have done some automated testing. We'll do a little bit more. We won't get to look at the operation and monitoring side, well, in particular the monitoring side of an application, which is a very important part because that really provides the feedback as to how your application is operating for your user base. And there are lots of really good tools and services that support that side of it. But we won't get around to that, unfortunately. Now, as I said, it's not that these are the only tools available and frameworks and services available. They're probably just a small subset. Many of them would be the most widely used, admittedly, some less so. But specifically, what we will be using is we'll be using Docker, which is the first topic that I'm going to cover in this module. We'll be using the AWS services, only a little bit though. I do have another module in the second semester called Distributed Systems, where we look more deeply at the AWS services that are available to us. We'll be using Git in the background. I'm assuming people are already familiar enough with Git. I may go back and look at some detail on it depending on the time that's available to me. We'll be using GitLab, although you can see GitLab is mentioned twice. It's mentioned here and it's mentioned here. It's maybe this side of GitLab and how it's used in the kind of automated testing deployment side. That is where we will be using the tool. GitLab also has a repository part to it, which makes it comparable to GitHub. And that's why GitLab is mentioned up here as well. We could just as well have mentioned GitHub here as another alternative. On the testing side, the testing framework that we will look at is one called Cypress. It's not mentioned here at all on this slide. I could have doctored it to bring it in myself, but testing will come at the back end of this module. So overall, this Agile stroke DevOps development lifecycle is what forms the context for what we will be looking at. But in particular, we are interested in the automation side of that lifecycle and particular aspects of the automation. The building side, the automated testing side, automated building, and automated deployment. Just pause for a second in case there are any questions. This is all at a very high level now, so admittedly, it's not easy to perhaps form a question, but I'll give you an opportunity anyway. No? Okay. So I've kind of already mentioned what's on this slide. Our focus is on the tools and services that support this very kind of dynamic development lifecycle environment. And I've already mentioned some of the tools that we will be using. I think I've mentioned all of them actually. Docker for both building, packaging, and deployment. So it hits a number of parts of the Agile process. GitLab CI for something called CI/CD. CI/CD stands for continuous integration, continuous deployment. So if I go back, it's, and also maybe clean up that slide. Next. My eraser. Sorry, I'm using the wrong command sequence. Just bear with me. Sorry, no. I had to change my own computer crashed last week, and I've had to switch over to another one. And the various keyboard shortcuts that I used to use on the other machine don't work on this machine, so I have to work out how to do it manually. Just bear with me if you don't mind. Okay, I'm gonna have to keep going because for some reason my mouse is not appearing on my screen. I'm not sure if it's appearing on your screen. No, okay, I'm gonna keep going, sorry. CI/CD encompasses the test, release, deploy part of that DevOps process. It kind of manages, or it allows you to automate the automated test, automated deploy part of that process. And you can see GitLab CI is the tool that we'll be using to achieve that. Okay, Cypress and Mocha are the two testing frameworks that we will use, and the AWS platform is what we will use to deploy applications. So we're not so much interested in developing applications. We're kind of taking applications that are already developed and using these tools that I've listed here to automate the whole Agile stroke DevOps development lifecycle part of them. Obviously, students are always interested in how is this module being assessed. It's 100% CA, and provisionally anyway, this may change, although it would only be slightly. I'm allocating 10% to lab work. Now, what that will mean is that, so we will roughly have, let's say, 10 labs throughout the semester. I will pick a small subset of those, to a maximum of 3, which I will ask you to submit, and they will form 10% of the overall 100%. There will be either 2 or 3 assignments. Well, if it's 2, then it'll be 40% each. If it's 3, it's slightly less than 40%. And there will also be what I'm calling an end of semester lab-based exam. So what that will involve is coming into one of the lab rooms, and I will set some tasks for you to complete over I don't know, maybe hour long or 1.5 hours. I haven't really thought about it yet, to complete and submit using either GitHub or GitLab. I haven't really tied that down yet, and that will be worth 50%. So it's a little bit like an end of term exam, if you like, but it's lab based. It's not pen and paper where you're writing stuff down. You're actually trying to achieve something on your computer. Again, I'll pause in case there are any questions. Okay, so if I go back to this image that I cannot clear up, the first topic I want to look at is the Docker tool. So if I go back to the website, we're now going into this section, and we will be in this section for a number of weeks, really. And I want to start looking at this set of slides here. Now, again, for me, when I click on this set of slides, they just don't want to load. I think that might be my particular browser. As I said, I'm working on a computer now that's about 15 years old. I didn't bother upgrading anything because I'm hoping to have my own computer back, hopefully by this afternoon. But I noticed in the chat in yesterday's lab that some of you were able to load the slides. So I'm assuming everybody can actually access those slides. They're in PDF form. Again, get back to me if you can't, and I'll put them up on Slack. And then when I finish today's lecture, don't know how long I'll be lecturing for now, then I'm going to let you try and start off at least this lab here, but that's for later on. Let's start looking at these slides. And I'm going to stop sharing for 1 second. Okay. So the topic is containerization. And the subheading there is that containerization will simplify application deployment. Now, you remember from my DevOps image that deployment was on that kind of top right-hand corner of the DevOps process. So that's where containerization applies, and it somehow simplifies. And really, what deployment means is you want to run your application essentially on a remote machine, which today means you want to run it in the cloud. So how do you actually do that? How do you deploy your application to the cloud, as we say? And the answer is, or an answer is, to use containerization. Before I talk about containerization, though, containerization evolved from something called virtualization, which may be a term that you've heard before. So this may be just reminding you what virtualization is about. And what virtualization allowed us to do was essentially, it was a process, I'm saying there, of creating an abstract layer over your hardware. So it essentially allowed you to have multiple parallel operating systems executing on one physical piece of hardware. So maybe if we look at the image, I'm trying to get my pen to work here. Yeah, my image on the right. Whether you're working on your local PC, which is where you will be working on, or if you are working on a larger computer server, or if you're working in the cloud, doesn't really matter. Which of these machines it has, that's our infrastructure. It has an operating system running on top of that hardware, which we refer to as the host operating system. Then if we install a piece of software called a hypervisor, what the hypervisor will allow us to do is to mount multiple operating systems on top of our single piece of infrastructure. And these multiple operating systems we refer to as guest operating systems. So for example, this might be a version of Windows, this might be a Linux operating system, this might be a Mac OS operating system. And we can run all of those on the one physical piece of hardware, and then run applications that need those operating systems within the boundaries of these guest operating systems. So that was a revolutionary piece of technology or technique that came about a number of decades ago, I guess, at this stage. And it allows us to run applications that were dependent on a particular operating system, run those applications on the one physical piece of hardware, even though the underlying host operating system was just a single operating system. The guest operating systems could be multiple versions of multiple different types of OSs. So that was virtualization. It was revolutionary at the time, but it's often referred to as being very heavyweight because each of the guest operating systems, they do consume a lot of hardware or infrastructure resources in terms of RAM requirements, network requirements, CPU requirements. They are quite heavyweight. The advantages, before we move off them, the advantages of virtualization meant that we minimized our hardware cost. So instead of buying, going back to the previous slide, instead of buying 3 pieces of physical hardware to run our 3 different guest operating systems, we didn't have to incur that cost. We just used one. So we can use multiple virtual servers on one hardware. It was relatively anyway, it was easy, I'm saying here, to move a VM from one physical piece of hardware to another physical piece of hardware. And this would be particularly relevant to kind of the cloud. If you look at the image at the bottom of the screen, you can imagine now in a cloud-oriented world, cloud computing-oriented world, you might have the cloud service provider will have pieces of hardware scattered around the globe. And it is possible to take a virtual machine, a guest OS, wrap it up and move it from, let's say, running on a piece of hardware in the US to spin it up and get it running on in the European region, okay, which was just unimaginable prior to virtualization. It also, I'm saying here, provided disaster recovery. So, if we just stick with one region, if you've got your guest OS running on a piece of hardware in one region of the US, and for whatever reason, the network goes down there, then it's possible to spin up that virtual machine in another region in the US and still allow your user base to access whatever application that guest OS operating system is serving up to the user base. It also kind of facilitated this follow the sun, follow the moon type idea. So, at any particular point in time, the user base in one of these regions are going to be active, and in the other regions they're not, because it's nighttime, right? So you may want to move your your virtual OS to the region where the sun is currently up, because that's where your user base is, and you want to make your guest OS as close as possible to your user base. And then when the nighttime falls in the US and it's daytime in Europe, then you simply shut down the guest virtual machine on the US side and spin it up on the European side, and it's now closer to its user base. Equally, if the nature of the processing that's being done by your application is more batch orientated, in other words, it's not being interacted with users, then your batch oriented applications, you really want to run those at nighttime. And so the reverse of the follow the sun kind of applies to batch oriented type applications. So overall, what we're trying to get at is that virtualization allowed you to move your applications around the globe in a much more flexible way than was possible prior to virtualization. So that was great. That probably kind of slide, I think, is saying much the same stuff. Let me just glance over it. I think so, yeah. The downside of virtualization, though, is that it's sort of quite heavyweight, as I mentioned there a while ago, because it did require each guest operating system or each virtual machine did consume quite a lot of the hardware resources of your physical infrastructure. Also, if you're running each guest operating system is running its own, each virtual machine, sorry, is running its own operating system. So you may be incurring a license cost to run that operating system. It's probably not as big an issue today as it used to be in days gone by. The second point is it has its own, that's okay. It needs maintenance. Any operating system needs to be maintained or needs to be patched, needs to be kept up to date. So that applies to your VMs as well, your virtual machine operating systems. You need to maintain them. And that's just extra workload. So there are costs, both time-wise and performance-wise, related to virtualization. And for that reason, that's where something called containerization came about. So the solution to the problems of virtualization is containerization. And the image, I think, on the right synopsizes where the difference between virtualization and containerization. In containerization, okay, we still have, let's say, your physical infrastructure, be it your laptop, some sort of heavyweight server, piece of hardware, or the cloud. There is a single operating system running on your infrastructure, as there always would be. And then we use what's called a container engine, which in our case, the container engine that we will be using is called Docker. And what that container engine allows you to do is to run multiple applications, but keep them completely isolated from one another. That was one of the advantages of virtualization as well. Your applications that were running within a VM were completely isolated and insulated from one another. And that was a desirable feature because if you're running these applications in the cloud, then you want to be assured that the applications cannot be accessed by other applications or accessed by users that shouldn't be able to access them. And that was realized with virtualization. Now we want the same kind of isolation principle to apply in containerization, and that is guaranteed. We won't look into the detail as to how it's guaranteed. Essentially, each application here is an operating system process in its own right, and OS processes, the operating system can guarantee isolation for you. But not only are each of these applications just applications, they also include the various third-party libraries and binaries and any other aspects of the underlying operating system that are required. They're actually all part of this unit here. So in a sense, each of these applications, it's a bit like its own operating system without the extra heavyweightness of the virtualization kind of concept. So we would refer to this now as a container, okay? And as I said, a container contains both the application code and all of the other third-party libraries and dependencies that it requires. And those dependencies would include operating system file system related dependencies. And each of my applications has its own requirements. There's no sharing of any files between these applications within each container, even though they're running on just one operating system, which is kind of a difficult thing to imagine, but that's what's achieved. We will see it a little bit later on, maybe how it's achieved. The nice thing about these containers is that they're highly portable. It only takes a couple of seconds to, as we say, spin up a container, which is not really the case with virtualization. It can take perhaps a number of minutes to spin up a virtual machine, but not so with a container. So they're portable, they're easy to build, and we will be using the Docker framework or tool to build our containers. They're quick to deploy. Again, it's milliseconds versus a number of minutes in the case of virtualization. And deployment is what we're all about here. This is where we're focused on. How quickly can we deploy our application onto a particular machine, whether that machine is running in the cloud, whether it's a hardware server, or whether it's our own desktop machine. They share the resources of the operating system, which is kind of what I was alluding to there. In terms of by resources now, I mean CPU, RAM, networking. They share those, okay. I'm also saying that they're highly disposable or ephemeral. So it only takes a matter of seconds to shut down one of my containers and restart it if I need to do that. It's probably not even seconds. It's something smaller than that. It's more than milliseconds. But and again, that's you could do disposability and ephemeralism. Okay, that's probably a quality within virtualization as well, but it's not as fast or as quick. It's not so much containerization versus virtualization. In fact, they often go hand in hand. So the diagram on the image on the right here of the picture is probably what happens in real life. We have a combination of virtualization and containerization. And so what we're saying on the right here is, if you think now in terms of the cloud in this case, running an application, you want to run an application in the cloud. Well, in terms of the various layers that might be that might apply to the physical piece of hardware in the cloud, there's the infrastructure side, the actual hardware itself. There isn't any guest operating system on your cloud hardware. The hypervisor software is actually running on top of the hardware. Remember, the hypervisor is a piece of software that we need to install on our hardware in order to achieve virtualization. We have a number of guest operating systems running on our hypervisor. That's classic virtualization. But each guest operating system, it has a container engine running on top of it. Specifically in this image, I'm saying it's the Docker container engine, but there are others, although we will only be looking at this one. So each guest operating system now has a piece of software called the container engine. And the engine then is where we deploy our applications on top of. So these are our containers in this case, running on top of a container engine, which is running on top of a guest operating system, which is running on top of a hypervisor software, which is running on your hardware. That's your classic stack that applies in any of the cloud services, AWS, Microsoft Azure, Google Cloud. On the left here is the kind of stack that will apply on your local machines, on your laptop. You'll have a host operating system, be it Windows or Mac. I will get you to, well, I mentioned yesterday that you need to install the Docker desktop application. That's really what this is, Docker Engine. And over the coming weeks, we will be able to run containers on your Docker engine. We'll be able to build them and run them. And later on, then we will actually deploy a container onto this environment on the right here using the AWS platform. Okay, that's the trajectory that we're trying to achieve. So the problems container solves, I've kind of alluded to them in passing. I'm seeing developers often face issues when working in different environments. Well, you know, in a software development environment, you're doing development, then you're doing testing, and then you want to deploy your application. Now, each of those three stages in the software development lifecycle you may be using different physical hardware. The development you're probably doing on your own desktop machine. The testing may be done on a server that you're connected to over the network. And the deployment, let's say, is to the cloud. So there are three different environments. They may have slightly different configurations. They almost definitely will. And that can be a real problem when you're not working in a containerized world, let's say. Because the operating systems that are being used on those three different infrastructures are configured slightly differently, and that is just going to cause headaches for the development team because they may need to make slight tweaks to their application in order to get it to run properly on those different environments, the development environment, test environment, and production environment. Production environment is really what is the cloud in our case. Yeah. There's also, we've all had this kind of situation where let's say we're developing an application and it runs successfully on our computer, and then we give it to a colleague and they can't run it on their computer. And again, it's the same issue. There may be a slightly different configuration of the underlying operating system on their machine, which is why they can't run it. But in a containerized world, as we saw from the previous screen, your containers are insulated in a way from the underlying operating system. They're not dependent on it. Yes, they use it, but they're not actually dependent on it in that they don't necessarily try and access particular files that belong to the guest operating system. Here I'm saying containers provide a consistent and isolated environment. Kind of already alluded to that. I mean, it's very abstract. I haven't given you specifics on it. We'll see a little bit about that later on, but that kind of consistency is what you're striving for. Because when I was talking about your different environments up here, we didn't have a consistent environment. They were all slightly different. We'd like a consistent environment right across the development life cycle, from development right through to deployment into production. The isolated refers to the fact that when we run our application in the cloud, then we want to be assured that it is completely protected and isolated from any other applications that might be running on the same physical piece of hardware. You know, because if I go back to that this image here and take the one on the right, this is representing your typical physical piece of infrastructure in the cloud. So there may be multiple applications, not all owned by you, but owned by different organizations, running on the same physical piece of hardware. And clearly you want to ensure that there isn't any kind of overflow between them. And containerization guarantees that and has been proven to to be successful. This is kind of making the same points really, so I won't labor it. You can read through those yourself. I'm just going to glance over them, just make sure I'm not missing anything. Portability, scalability. The scalability one there is often when you deploy an application to the cloud, you actually want to run multiple instances of that application. And that may be globally. You may want an instance of your application running in Europe, another instance running in the US, another instance running in Asia, if your user base is global. So, or indeed, if your application is currently running in Europe and there is a very high user group trying to access your application, then you may want to spin up multiple instances of your application across multiple pieces of hardware, cloud hardware in Europe. You want to scale up your application, in other words. With containers, that's achieved in a matter of milliseconds, but not so with virtualization. So it scales very well. Cost effectiveness, kind of already alluded to that before. Reproducibility and replication, that's okay. Yeah. Containers, okay, they have all the good parts of virtualization, which I've kind of mentioned. Virtualization has scalability, isolation, portability. It has all of those characteristics as well. But as I've already said, probably too many times at this stage, they're not as quickly achieved as they are with containers. And speed is of the essence when you're running any application in the cloud. This is a nice image I got somewhere which kind of compares containerization and virtualization. And we can see that everything on the right is, is multiple factors, bigger, slower, faster, or bigger or slower, I guess, than the list, the containerized alternatives on the left. Sorry, the virtualization is these are the criteria that we're looking at. I mean, the image speaks for itself, but virtualization is always slower and bigger, whereas containerization is on the opposite side. Now, there are two constructs, I suppose we call them, when we are talking about containerization, and these two terms will become very familiar to you after about a week or two of using the Docker framework. We talk about images in the containerized world, and we talk about containers, hence the term containerization. So an image is essentially kind of a packaging of your application, whatever the nature of your application is, whether it be a React app or a web API or any other type of application that you've ever developed. Any application can be containerized. Possibly the only exception might be an Android application, because I don't think containerization runs on Android as such, or at least I haven't seen any example of it. But outside of that, any application can be containerized. And so when you have an application, the first thing you've got to do is to create an image of that application, which is, as I said, a kind of a way to package the application. And Docker will do that for us. Now, in this image, I'm saying it includes everything needed to run your piece of software, i.e., it contains your application's code. It contains any third-party dependencies or libraries that the application needs. It contains any system, i.e. operating system tools that it depends on, any operating system libraries that it depends on. It contains any configuration files it depends on. They are all contained within the image. And again, I know I've said it once or twice, but I will repeat it. When we're talking about system tools, operating system tools and libraries, each image will have its own copy of whatever system tools and libraries it needs. It doesn't reach into the host operating system to access them from there. It has them contained within the image. So the entire file system that an application needs, that is contained within this construct called an image. And really an image is just, you can think of it as a file, although it's a bit more than that, but it's let's refer to it as a unit, a static standalone unit that you build with Docker. It's immutable. You can't edit an image. All you can do is create a new version of the image, okay? But once you've created the new version, then that's immutable as well. And an image is, I'm saying it's a template for a container, which brings us on to a container. You can't talk about one without talking about the other. The container now is the runtime instance of an image. So an image is kind of a static thing. A container is a dynamic or executable thing. So a container is a runtime instance of an image. It's what the image becomes in RAM, essentially, when you try and run it. It's an OS from an operating system's point of view. A container is an operating system process. We are familiar with operating system processes from our earlier studies, and we know that operating systems processes are isolated from one another. The operating system itself guarantees that. And a container's file system, well, a container's file system comes from the image that that container is running. Okay, so two constructs, images and containers, but it's important that you understand the difference between them. And once you start playing around with Docker, it'll become much clearer. Which brings me on to Docker. So Docker is one containerization technology. There are others though, but by far and away, it's the kind of original, and arguably it's still the most popular. Just check my watch to see how we're doing at time. Okay. Okay, it's an open source platform for creating and managing container-based environments. In other words, it's containerization. It simplifies the development and deployment process by providing a consistent environment that's okay across different machines. So this Docker technology runs on any operating system. What Docker, and really is kind of a byproduct of containerization, really, what Docker allows us is to easily allow us to share and distribute applications. So I might have an application that I've developed and I want to share it with you. And as long as we both have the Docker technology, Docker engine installed on our computers, in other words, using the Docker desktop, then I can give you the image that I have developed and you will be able to run that image. Now, let's supposing I develop the application that I want to share with you using, let's say, a language called Go. But you don't have the Go language installed on your computer. That's still fine. The Go application will still run on your computer. And that is the beauty of Docker. There are no special installations that you have to do on your computer in order to run an application that I have developed using a language and maybe some third-party libraries that you have not installed on your computer. Okay, the Docker, that's coincidentally that I mentioned Go there. That's purely coincidental. Let's say I develop my application in a language called Rust, which is a new kind of language on the scene that you may have heard of. I've developed an application in Rust, and I've created a Docker image of that application. I can give that image to you, and you will be able to run that application on your computer, even though you have not installed the Rust runtime or any of its command line tools. Docker itself was written in this Go language, which is a language provided by Google, released. So it's been around for quite a while, since 2013. Originally, you could only run Docker on a Linux platform, but that has changed since, and that's the beauty of the Docker desktop tool. Docker desktop is available on both Mac and OS and Linux. So hence we can run Docker on our Windows machine, for example. Architecturally, this is how we might describe Docker. So on the left, there is a CLI, command line interface, that we can use. Now, if you have already installed Docker Desktop, you have that CLI available. There's also a GUI version of the client, I suppose, on the left. Although we will use the command line version of it, but once you become comfortable with Docker, you may want to switch to the GUI side of it. But I would recommend that you stick with the command line version of the client. Then in the middle is where all the action happens, really. This is the Docker engine, is the middle block in this image. And there are a couple of parts to it. There is a Docker daemon process, and it's that Docker daemon process, that's what you are communicating with when you run any of your command line instructions from the left. You're essentially communicating with the Docker daemon process. And also within the Docker engine, that's where when you build a Docker image locally, my mouse disappeared again. When you build a Docker image locally, then it stores the image within the Docker engine itself. Also, when you create containers that you want to run locally, those containers are managed by the Docker daemon process. And then on the extreme right, there is an online registry where you can upload your images to. And that registry then is what would allow other people to download your image and run your image in a container on their computer. So client on the left, we will use just the command line version of this client. In the middle is the Docker engine, and the most important part, arguably, of the Docker engine is the Docker daemon, which is just an operating system process. And on the right then is the registry where this is what facilitates sharing of images across the globe. And I think I have mentioned everything on this slide as I described the previous one. So that's okay. There are a number of Docker registries out there. The one that the Docker team themselves provide is one called Docker Hub. You may have heard of it already. So it's kind of the default registry, but there are other ones. GitHub actually has a Docker image registry within it, as does the AWS platform. We will, I think, only use Docker Hub, but it's quite easy to use the other registries as well. This is the very basic workflow, which you could kind of predict. The first thing you do is you create an image locally of your particular application, whatever the application is. Now, to create the image, you do have to create, you've kind of got to describe the image or describe the building of the image. We talk about building an image. That's the verb that we use. You describe how an image is built in a file called the Docker file. And in about 2 or 3 weeks' time, we will start looking at Docker file and how we describe as a set of kind of directives as to how an image is built. Then once you've created this Docker file and from it created the image using, if I go back to the previous slide, using the Docker build command there on the left. The next thing you might do is start up a container to run that image. And again, we use the Docker CLI to do that. Again, it's a simple single command. So you start up, you tell the Docker daemon that you wanted to create a container, and within that container, you wanted to run a particular image. Then if we are happy that we want to share that image with other people, we push the image. It's an image that you push now, not a container. We push the image up to our registry, whether that be Docker Hub or any other registry. Other users then can pull that image. You can have public and private images. Clearly, it has to be public if you want other people to use it. They pull the image down onto their local machine, and then they can run a container of that image, running that image. The basic commands there at the bottom of the screen, they all begin with Docker. This is what you type from the command line. So Docker build, that creates the image. Docker push is obvious what it does. Docker pull, it's obvious what that does. Docker run is where you're creating your container to run your image. Docker PS, for example, gives you a list of all of the current running containers on your local machine. Docker stop start is where you just kind of temporarily freeze a container and then restart it again. You can also delete containers, delete images. This is a nice image I found which kind of describes your workflow, although there are parts of this image that aren't recommended, let's put it like that. But if we go from the top left, so let's supposing we're just hosting our application code on GitHub, and within our application code, there is a file called Docker file, the one that I told you that you need to include with your application, describing how to build an image of your application. So you simply, I guess, you pull your application code from your GitHub account. It will have the Docker file within it. And then using the Docker build command, you create an image of that application. You can tag the image as well, which you'll see later on, which is kind of giving an image multiple names. Typically, the next thing you would do after the build is you might, let's see, do the run. You want to run the image in a container locally. You may do some testing of the application. Then you can push your image up to Docker Hub registry. Another user can pull down the image and run it locally. The other parts that are mentioned here, like the fact that you can, once you've got a container running your image, you can actually connect to that container and make changes to the image and then commit those changes back to the image itself, although that is not at all recommended, okay? It's possible, but it's not recommended. You might remember I said images are immutable and ephemeral. This kind of commit action slightly violates that, so we don't ever do that. What else have I got to do? Stopping, okay, you can stop and restart an image, which is really like pausing a process, an operating system process, and reigniting that process. So that's a kind of a nice visual of the workflow that you will be going through in the labs for me. Now, ideally at this stage, what I would do is I would give a demonstration, and you know, as I work my way through this module, demonstration is a big part of my lectures, but because of the issues that I've had with my local machine last week, as I said, I'm making this presentation on a computer that's pretty ancient and doesn't have any of the software that I need on it, so I cannot do the demonstration for you. Ideally, what I'd like to do is do a demonstration and then let you work through the lab, and where the lab kind of covers the same steps that I would demonstrate to you. But because I can't do that, I'm just going to still, though, if I go over to the website, I'm going to ask you to just go into the lab and see how far you can get through the lab. It's a very prescriptive, the lab, so it tells you exactly what to do, what commands to submit from the command line, what to look out for when you've submitted those commands. Now, if which you may well be, if you're very unsure what exactly is going on here, then I will certainly give a demonstration next week, because I hope to have my own computer back next week where I can do a demonstration for you. But I would like you to make a start on this lab anyway. As I said, you may well be able to work your way right through it, but you may be a bit unclear as to what exactly is going on, but still you'd have gone through the process. And then I can explain it next week, which is kind of cart before horse, but there you go. So I'm going to stop talking at this stage, and whatever time remains, I'd like you to have a go at this lab, and I will monitor the Slack workspace if you're having any issues, and by all means contact me on Slack over the next hour or so. Before I shut down this meeting, of course, I should allow you to ask any questions that you might have. Probably should have given you an opportunity as I work my way through the slides, but are there any questions immediately that you have?
Yeah, I have a question. Can you hear
Great.
me? Yeah, I'm just going to ask you. I'm not in the Slack channel. I'm trying to register, but I'm having issue registering it. So, would that be a problem?
Did you get the link to join the Slack channel?
No, I'm not. I haven't registered yet. I'm waiting to be registered when my results comes.
If
So I
you
haven't
send
registered
me an
yet.
email, then I will be able to respond with the link that will allow you to
Perfect.
join the Slack channel. I'm assuming you have a Slack account.
Yeah, I do.
Yeah. So if you just send me an email, there doesn't have to be any just brief one-liner telling me that you just asked me to allow you to join the Slack channel, and I can also enroll you on Moodle if you give me your student number.
All right, perfect. And another question is that, do you know the requirement that we need to do with the AWS and the
Mhm.
Docker? Do we need to use our personal email addresses for it, or do we have to use the college one?
It doesn't actually matter, but I guess can we just think now? I guess it would be better if you use your set2 email. I mean, you can always later on, you can always create another AWS account with your own personal email, if that's what you'd like to do. But I'm just trying to think out loud. There isn't any reason why there isn't any real reason I can think of off the top of my head why it has to be your Setu email. So I'll leave it kind of open-ended. Use whatever email address you want to. Yeah,
All right, thank you.
great.
And also, there's a question in the chat. It says, can you remove the permissions from Moodle so that we can have access to the slides?
To access Moodle?
Yeah, so no, you know you have like permissions. You have put like a restriction on the Moodle content for the slides. So can you remove that restriction?
I'm not sure what that question is about now, actually. Is it about registering on Moodle, or if it's accessing the PowerPoint slides?
Yes, that is it.
Yeah,
Yeah.
it's the PowerPoint slides are not on Moodle. The PowerPoint slides are accessed from this website, which I gave you the URL of, unless the question is about this problem that I'm having, which is when I try and access these slides, it doesn't work unless the person is asking that question, how can they access these slides? In which case I will put them up on, I'll publish them on the Slack channel and you can download them from there. But ideally people should be able to access the slides from here. The slides should actually load up here now properly, but you can see it's not working. But I think that's because, in my case anyway, the browser is just too old and I haven't bothered to upgrade it because I know I'm not going to be using this computer from next week onwards. So if I think I'm only assuming that's the question that the person is asking. But just to elaborate again, I don't really use Moodle for anything other than submitting assignments, and that's not an immediate requirement. Okay, that's good. So, as I said, have a go at this lab here. Of course, it assumes that you have already installed Docker Desktop. That's the prerequisite. And chat to me on Slack if you're hitting any problems. All right, we'll leave it at that for terms of the Zoom meeting anyway. So I'll talk to you again next week. Bye-bye.